This video is reviewing section 7.4, which was all about inverse functions. So in 7.4 we talked about the most basic piece of an inverse function is that inverses switch the x and y. So if you were given a list of coordinates and asked to find the inverse, your x's would become your y's and your y's become your x's. After that, the next piece that we do in that section is we identify how to find inverses. So that's what you're being asked to do here. You're given functions and you're asked to write down what the inverse of each function would be. So when you go through this, first thing you want to do is you want to write it in more of a y equals notation. Then you want to switch your variables, so switch your x's and y's. And your last step is to get y by itself, to solve for y. So I'm going to multiply both sides by 6. So I get 6x equals y cubed minus 5. Add 5 to both sides. So 6x plus 5 equals y cubed. And then my last step is to take the cube root, or the 1/3 power on both sides. So my inverse is the cube root of 6x plus 5. And the notation that we use is we use an f with a -1 next to it. That is the symbol for inverse. You could also write a y with a -1 next to it. Again, the symbol for an inverse. Same process with the next one. So we're going to start off by writing it as y equals -5x minus 7. And then turn around and switch the variables. So x equals -5y minus 7. Get y by itself. So we're going to add 7 to both sides. So x plus 7 equals -5y. And then finally divide everything by -5. Try to get in the habit of doing it individually. So you get -1/5 x, or -x over 5, however you want to write it, minus 7/5 equals the inverse function. The next thing that we did with inverse functions is that we talked about how we verified inverses. Verify is a little different. You're not actually finding inverses. Instead, you're going to be given two functions that basically we're telling these are inverses, but you need to prove it. And the way we prove it is we do a composition. We actually do a composition both ways. We want to find f of g of x, and then we want to turn around and find g of f of x. It does not matter which one you do first. So I'm going to start with f of g of x, so that means take the g function and put it in to the f function. So it's going to look like this. You're going to have the cube root of 5x minus 1 cubed plus 1 over 5. So the cube and the cube root will cancel. And a lot of times here you're just going to have a lot of slashing kind of written going on. So you have 5x minus 1 plus 1 over 5. Now the minus 1 and the plus 1 cancel. And then finally you have 5x over 5. The 5's will cancel. And you end up with x, which is exactly what should happen if they were indeed inverses. You should have everything canceling with the exception of a single x left over. Now I'm going to go the other way. I have to show both compositions in order to get full credit for this. So now I'm going to take f of x and put it inside of g of x. So you're going to have the cube root of 5 times x cubed plus 1 divided by 5 minus 1. Your 5 divided by 5 will cancel. Your plus 1 and your minus 1 will cancel. And then finally you'll have the cube root of x cubed, which will cancel. And when you are done, you'll have x. So anytime you're asked to verify or prove that two functions are inverses, you have to do both compositions, put one inside the other, and then turn around and put the other one inside the other one. And both of them should be equal to x when you are done with doing the composition. And then one of the last things we talked about with inverses, we talked about the visual idea. One thing we know with inverses is if we graph a function and its inverse, you see a reflection over the line y equals x. This is actually asking you to do something a little bit different with the graph. It's asking you to graph the original function and use that picture to determine if the inverse would also be a function. So when you look at this first one, you have f of x equaling -x squared plus 5. So you can pull out a calculator, or you hopefully know what -x squared plus 5 looks like. It is a parabola. It is upside down. It's been shifted 5 places up, so it looks like this. And I just need a rough sketch. I don't need anything really specific. If I want to see if its inverse is a function, I'm going to do what's called the horizontal line test, or the HLT. Meaning if I draw a horizontal line, it should only touch this function in one spot at most in order to have an inverse function. And you can see this one breaks the horizontal line test. It would touch it twice. So we would say no, because it fails the horizontal line test, which we're going to abbreviate HLT. The next one is a function -2/3 x plus 2. So again, I'm going to draw a little sketch, or you could definitely graph it on your calculator. But I know what this looks like. This is a line. It goes through 2 on your y-axis, and it has a slope of -2/3. So down 2, right 3. So we have this oblique line. And again, I'm trying to figure out if the inverse of this line would be a function, so I'm going to perform the horizontal line test. Any horizontal line that I draw, no matter where I draw it, will only intersect this once. So therefore, yes, because it passes the horizontal line test. So being able to have a visual either at your disposal or using your calculator to get a visual will help you determine if the inverse is also a function by doing the horizontal line test. And those are some of the main skills you should have that you should be comfortable with when you're going through section 7.4 and getting ready for the inverse part of your chapter 7 test.